Good morning. Today I am going to discuss about the case studies of packaging and processing solutions to improve meat quality and safety. Introduction. Meat sustainability it can be improved by increasing productivity or by reducing waste and spoilage. Shelf life of meat it can be defined as the storage time until spoilage, which mainly depends on the number and type of microorganisms. Bacterial growth is determined by the storage conditions, that is, temperature and packaging type. Active packaging systems it have a great potential to reduce waste through chemical and microbial control of the product or storage environment. Although the commercial products are already available, active packaging is far from being fully developed. In contrast, passive packaging such as modified atmospheric packaging and vacuum packaging have been fully implemented. Research conducted at the Danish Meat Research Institute DMRA it demonstrates that it's possible to create new opportunities for the meat industry by modifying MAP or combining microwave treatment with vacuum packaging. Objective. The objective is to predictive. The objective we can say the predictive shelf life models it can be used to estimate the shelf life in modified atmospheric packaging or vacuum under dynamic temperature conditions. The aim of this article, that is objective, is that the fresh meat shelf life modeling, dry gas modified atmosphere packaging, and in packaging microwave decontamination. All the three solutions are examples of industrially driven research conducted at DMRI based on modification of existing passive packaging systems and their interactions with well established processing technologies to create new quality and safety improving solutions. The experiment was designed as two sub-trials, one trial for documentation of the shelf life and other trial for documentation of the eating quality. For both sub-trials, long Longissimus thoracis it lumborum LTL it was selected on the same day of slaughter at an Australian beef processing plant, vacuum packed and exported to Denmark by boat. On reaching the DMRA pellet plant in Denmark, the LTA was cut into 1.5 cm sticks and repacked for retail display using one of the following four packaging methods. First, dry gas MAP at 30% O2, 30% CO2 and 40% N2, high O2 MAP which is 70% O2, 30% CO2, vacuum packaging and overwrap, that is MAPET trays wrapped with oxygen permeable PVC film. Then during retail display, samples were analyzed to quantitate effects of sensorial quality and microbial growth of raw meat. Sensory attributes were analyzed twice during storage, day 0 and close to the expected use by date, that is day 3 for overwrap, day 7 for MAP and day 18 for vacuum packed meat. The expected use by date was determined by using shelf life predictive models and performed a pre-study on repacked Australian beef, that is LTL, in MAP, which is 70% oxygen and 30% carbon dioxide and vacuum. The meat for the pre-study it was purchased from the Danish supermarket chain that sells meat from Australia similar to that of the main trial. This ensured the comparable selection criteria, slaughter conditions and distribution. Results and discussion. Microbiological analysis of 5.8 GHz microwave treated samples are shown in figure 5, and it is seen that the spore counts of Clostridium botulinum decreases over time. After 3.5 minutes, the number of Clostridium botulinum spores on the surface it is reduced by approximately 5 log reduction. The d value for the microwave treatment it was calculated to be 0.79 minutes. The 6 log reduction in this the number of heat resistant Clostridium botulinum spores it can be achieved after approximate 4 minutes of treatment with microwaves at 100% effect. The advantage of using this microwave is that it has thin water film between the packaging material and the meat surface, which is immediately heated to 100 degrees Celsius without heating the center of the meat. This results in an increase in the death rate of the spores. In a water bath at 90 to 95 degrees Celsius, it happens. It is important to note that the water bath treatment at 90 degrees Celsius results in 6 log reduction of Clostridium botulinum spores after 23.9 minutes, which is longer than the 10 minutes recommended by FSA. Higher heat resistance is applied to the spores, which could be the reason for this extension of the treatment time. The results show that the time taken to obtain a 6 log reduction of Clostridium botulinum spores it can be reduced 6 times when using 5.8 GHz microwaves compared to hot water at 99 degrees Celsius. The shorter treatment time with 5.8 GHz microwaves is due to the faster heating of thin water film between packaging material and the meat surface. Commercialization of the developed technology, the main barrier to overcome is upscaling of the microwave power available for decontamination to the level required for typical industrial meat processing throughputs. Conclusion: the three industry initiated developments involve passive packaging systems and exemplified by DMRIs, shelf life models, tri-gas MAP packaging, and high frequency microwave surface decontamination of vacuum packaged meat. Using the tri-gas guidelines, the industry can benefit from the increased eating quality and in package decontamination process using vacuum packaging in combination with 5.8 GHz microwaves eliminates Clostridium botulinum spores, resulting in increased food safety and an extended shelf life. Furthermore, after the microwave processing resulting in a 6-log reduction of Clostridium botulinum, it is possible to extend the shelf life at 5 degrees Celsius to more than 10 day, for more than 10 days recommended by the FSA. Before implementation of the technology in the industry, the equipment must be upscaled and further experiment should be performed on cuts relevant to the industry regarding dimensions and volume. Thank you.